Okay, hello everyone. So, yeah, sorry a little bit late because of previous introduction. Okay, if you're interested in the event, you can join the event. Okay, so uh, our lecture today, we will maybe continue a little bit of our chapter 5, a little bit review, maybe a little bit example, and we will move to chapter 6. Okay? And um, your midterm result, because your TA had that trouble last week, so maybe next Monday or Friday, but probably Friday because he will give me on Monday and maybe not in the morning. So I need to check first from TA, and also uh, maybe I will prepare some make-up exams if the average is not good. And maybe the exam will be, so let me write make-up exam. So this will be the score will be the all score will be around 35% to 40, and the new score will be 65 to 60%. And you need to at least prepare the availability on weekend because I think I can find a good schedule on weekend. Because on weekdays, it's difficult to find a class with a huge number for students. Like finding 50 students, 60 students class is a little bit difficult on weekdays. So I prefer the weekend, but not sure when. Okay, so hopefully we can get the result and I can arrange some makeup exam. So the makeup exam, this will be optional. Okay, it's up to you. It's up to you. So it depends on uh, how much you get from the midterm result. Okay. If you get too low, I think you can join the makeup exam. Or if you already good or maybe high, maybe no, not necessarily. Okay. So the results, let me write down the results for the midterm. This will be on next Friday. So you need to come to the class next Friday to receive your midterm results. And if you have any complaint, you can complain on that Friday. If you didn't come, so your score will be as it is from the uh, from your TA. So your TA uh, will score uh, your results. Of course, I also observe how the TA give you the score. And also, we'll have quiz next week. Also the same day with this Friday. This is will be chapter 5, about chapter 5. So please practice and so exercise and practice. Also watch the new video, watch the additional video. Okay. Okay, that I think that will be our introduction. So the lecture, we will start with the uh, feedback, last feedback. I think the first question is I think too easy for you. Uh, it's asking that if we have this two integration here, and the question is asking integration from 4 to 8, that means we are going to have these equations. We can have these relations, and we know that the result will be 7.3 minus 5.9, which is the 1.4. 1.4, yeah. Okay, sorry for the one who answered this. I forgot to include the comma because some of you write with a comma. But the default writing for numbers in, I think, mostly generally will be with that point like that in the computer, in the computer. Okay, that's the first one. The second one is a little bit tricky that you need to remember the piecewise functions. This one, the f of x is equal 3 when it's when the x is less than 3, and f of x will be equal to x when it is equal 3 or greater than 3. So that means at least we can graph the the functions. So this will be the x equal 3, and this will be y equal x, right? And the question is asking what's the evaluation of the integral from 0 to 5, okay, from 0 to 5. So if we look at the picture and we know that the integral is area under the curve, then we need to calculate all the area that we have in our picture. And this x equal 3 becomes our points that we need to keep in mind, because on that point, s less 3 or x greater than 3, this will determine how our graphs looks like, right? So we have the area one is 5 by 3 or 15, and the little triangle will be 2. So combine both of them, it will be 17. Okay. Yeah, and this is a survey, and yeah, that's why from also from what the PA said that I checked some results, and I think we need to have some makeup exam. Okay. Okay, that will be the feedback. Okay, let me continue a little bit. Uh, I think we already arrived at this symmetric functions, right? Okay. We already discussed a little bit, and probably I will show you. Let me check first. Okay. Okay. If we have integration from negative a to a, fx dx. Okay. If you want to break down what the symmetric functions really means, okay, we can break down this into these two integral. Okay, and then we can also switch the first one and take negative. This is from 0. Okay. Now to make it more easy to follow, we need some substitutions here for x, okay? Or we change for u with the equal with the negative x. Okay? That is, if we have the du, this will be negative dx. Why I need this negative x? I want to remove the negative from this the first one here. Okay? So I will exchange x with u. Okay? So this will result f negative u. So it will result with, and this also changed. I forgot to make sure. So when x is 0, u is 0. When x is negative a, u is a. So this will get the same similar form between these two. So this will be f minus u du, okay, and plus 0 a f of x dx. Now the problem will be on this negative u here, okay, and from here we can determine how this will result if the function even or odd. Okay. So if the f even or the function even, then this will be resulting the original function fu. If f is odd, then this will take the negative form. Okay. Now from here, we know that if we have f even, then the point from here is true, right? This will be twice of the integrations from 0 to a. Okay? If that is odd, if the function is odd, then it will subtracting completely and resulting 0. Okay. So determining the functions to be even or odd, sometimes it can make some integrations that looks complicated. Maybe we can have an easy solution for those integrations. Right here, this will be 2, and this will be 0. Or maybe this one going here or going here. And then also, we also can think from the visuals. Okay, so if we draw some even functions, maybe like this, wait, like this, from A to B, you know that this will be, we can just calculate from 0 to B and then multiply by 2 of f of x dx, right? If this is f of x. And if we have the odd function, we can also, like for example, this one, we see that this area will be subtracting each other. So it will become 0, right? That's I think also you can also think in the picture. Okay. Okay. Wait a minute. All right. Now let me give you an example on chapter 5, especially for substitutions method and how we are going to identify mostly the functions or which we can substitute. Okay. Let me give you an example. First part is, so I'm giving 3 parts. Each part I'm giving 2 integral. It seems looks similar, but it's actually different in a solving. And you can think which one is better, the left one or the right one. That is maybe which one is easy to solve. And let me give you a few minutes, couple minutes, or maybe 5 minutes to check and try by yourself. Uh, you can figure it out how to determine the integrals, okay? How to identify the substitutions, which element you want to substitute, okay? Oh, okay, sorry. I don't know what happened. Let me check. Oh, I think I know how. Why. Oh, okay. Wait for a moment. It's changed its Wi-Fi on its own. Okay. Okay, now it's better. Okay. Okay. Now between these three parts, we have like a battle. Okay, left and right. I think the difficulty will be mostly on the right side, right? The left side you can directly substitute and then solve the integration. Like from this, the first one, you can look at secant to x, tangent to x. First, you can think from what is a function that you derive resulting secant x tangent x. It's a secant, right? It's a secant. And it has 2x. So if you derive secant to x, it will be 2 secant to x. So to become the integral, you need to have half secant to x plus c. Okay, if you have more practice and more familiar with the derivative, you can do it the left one, the number one, within your head. Okay, no need to calculate. But if you need to calculate, we can substitute 2x with u. We can substitute 2x with u. Let me write here. Let me put the whole thing down here. So let's start from this one. We can check this with the 2x like that. And the du will be having 2 dx, in which we will have half secant u, tangent u, du. And we know that this result will be half of secant, right? And u is 2x, so this will be 2x plus c. Or we can also think from the integral, or from the derivative, that is, if we have the function of x is secant x, we know that the f prime x is secant x tangent x. So if we have f of x is secant 2x, we will have this will be 2 secant 2x tangent 2x, right? So the integral will be the solution. So integral of secant 2x tangent 2x dx will be half of secant 2x plus c. Okay, so you can have this method. The second one here, the right one, we have secant squared and tangent squared. Okay? Now, before we solve this, okay, first we need to think what is the relations between these two. Okay, if we remember the tangent, this will have secant squared, right? And if it will be nicely done if we substitute with u, du will be secant squared x dx. That is, we will have cancellations perfectly with the secant squared x within our integration. So we will have integrations u du, right? Or one u squared, sorry, u squared. This will be 1 over 3 tangent x with power of 3 plus c. Well, this is also can be done within the guessing method, like usual. If you check that if we have, we need to make the tangent squared, because if we have f of x tangent x, the f prime is secant squared. Okay, So if we need to have tangent squared, then we need to maybe add first maybe adding tangent squared like that, and this will result to tangent x and then secant squared x. Maybe we add more, and we will have uh, tangent cube x, and this will be 3 tangent squared x and then secant squared x because of the chain rule. So we have now the form that we are it's similar with the question. It's 3, and we need to multiply with the 1/3 to remove the 3, right? To remove the 3. So we can also use the guessing method. But the guessing method, you need to familiar with the derivatives. Okay? You need to be familiar with the derivatives. That's the first one. Any questions? The first one. Any question? Maybe online students. Do you have any question? I think no. No, right? Okay. Okay. Now move on to the second part. Let me move this to going to up here. This will be going to here. Okay, the second part, the left one. I think the left one is uh, not difficult, right? We can think from sine and cos is always complementary. The derivative of sine is cos, and the derivative of cos is negative sine. So if we choose to remove the 1 plus cos x, we can do that as well, and making them as u, like this one. And this will result negative sine x, which will cancels our sine. So we will have a negative, and then this will be 1 over u du, and the x, don't forget to change the x. So when x is 0, u is 1. Okay. When x is pi over 2, u is, oh, sorry, u is 2. This is 1. So this is from 2 to 1. This will result ln u from 2 to 1. This is ln 2 minus ln 1. Oh, sorry, ln 1 minus ln 2. This will result ln 2. Okay. Okay, what about the right one? It seems similar, but we just add the squared on the cosine. It is making the equations seems difficult to solve with just a regular U-sub. Right? Firstly, maybe you think that because you see that the first one have the 1 plus, and you know that 1 will be gone when you derive. The right one also have 1, and you think that 1 will be also removed if you derive the whole thing here. But when you derive cos squared, uh, it seems that it will have cos and sine, and it will not completely erase the sine because you will have another cos. Yeah, so that is a little bit trouble. But trust me that this can be solved through substitution. So this is when we are going to see the differences and how we are going to look on more details on the problems that maybe before or previously when we studied the integral, we substitute directly, maybe just the whole thing, and then, okay, we got the result, we can integrate. Now we need to substitute really, really in detail. Okay, we need to look on the details, identify which function it is. Any idea? Uh, yes, good, good. Yes, 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 yes. Okay. Good, good. Useful. Okay, good. Okay, so the first thing is in U-substitutions, we need to think a function that we need to substitute. And when we derive, we need to erase the other element, right? We need to cancel the other element. The first one, the left one, we can use the whole thing 1 plus cos x, and it will be uh, the derivative is minus sign. We can erase the minus sign completely, right? And this one, what function that you still have similar to the left, and you can cancel. And I think it's just cos x without 1, right? Just a cos x. We can erase this sign, right? But then the functions will be 1 over 1 plus u squared. And you need to remember what kind of function it is, right? 1 plus 1 plus x squared. Okay, so if we have 1 plus 1 plus x squared, this is a tangent, right? Tangent inverse x. So if we are going to substitute the cos x, it will have a negative sine x dx, right? We can erase completely, and we can take this in terms of negative, and then 1 over 1 plus u squared du, and don't forget to change the x to u, so x0, then u will be 1, x is pi over 2, u will be 0. So this will start from 1 to 0. So this will result in minus tangent, minus, maybe with a bracket, tangent inverse 0 minus tangent inverse 1. And it will result, this will be 0, this will be pi over 4, right? Tangent 45 is 1. So this will be pi over 4. Okay. Okay. Now the third one, the third part, the left one, I think it's easy to follow because it has x squared, right? X squared minus 1, like this one. And we can involve all x squared minus 1 into our u. And we can have our derivative will be 2x. And we can cancel this 2x with the x, right? We can have this 1 over 2x du. So we can have our integrations will be square root of u du. And this will be u half, okay? So this will be u, or x squared minus 1. I will write directly. 3 over 2, 2 over 3 plus c, and half, sorry. So this will be 1 over 3. Okay. I think the left one is not really a big problem, right? But when we remove the squared and making just x and square root x minus 1, we need to think in another way. Okay? Still, we can solve with the substitutions method. We can solve with substitution. Okay, good. Okay, now we really need to have another way in to solve this integral. Oh, Helen. Which one? This the sine, or this one? The left one, or the previous, or the second one here? This one? Okay. Okay, so for this one, the x square root of x minus 1, let me write u is x minus 1. Okay, let's just try, okay? Because in substitution, sometimes we need just to try with some u and then try to exchange whether we can find the results or not. And we tried to derive, became the u equal the x, just that. Okay, and then if we are going to implement in our integrations, this will result x squared of u du. We still have problem with this x, man. But if you think and if you look closely what the relation x it has with u here, we can exchange x with u plus 1, right? Okay. And then we can write this as u plus 1 and multiply with u half du. And from here, we can exchange, or we can multiply each element. This will become u 3 over 2 plus u with power of half du. And we can integrate both of them easily. And this will be plus 1 will be 5 over 2, right? 5 over 2. I will directly write with x minus 1. This is 5 over 2. And this will be 2 over 5 plus. This will be x minus 1, 3 over 2, 2 over 3 plus c. And that's our answer. That's the answer. Okay. So sometimes you can have this kind of situation where you when you have the when you apply the substitutions, it's not completely substitute the element, but when you think closely, look the x, we also have the relation that has include x, and we can also exchange those x, okay, with another u. Okay, in this case, it's u plus 1. Okay. So I hope from all these 6 example, we can have some idea on how we are going to identify the substitution. Okay. And substitutions method is, I think, in integral, uh, is one of the best way to look at and to solve the integral, okay? Because it can be applied easily. Okay. The other method that usually can solve most of the problem is we call integration by parts. Integration by parts. We will going to discuss maybe in the next 2 chapters. Okay, in the next 2 chapters. Okay. Let me give you one I think one more example to, to think. Okay. Okay, let's try this. 1 over x cubed plus x. Yeah. And now I'm rising the level. Okay, rising the level. Try this one. 1 over x cubed plus x. Maybe make it a little bit bigger. Now this is a little bit advanced, a little bit advanced, but still we can solve it. We can solve it. At least there is 2 methods to solve this. Two methods at least. Yes, yes. Yeah, can you solve it? Can you solve? Mm-hmm. Mm-hmm. Wow. Cari lagi yang lain. Okay. Seems difficult, right? Seems difficult. Yeah, the probably the first idea that you can think, maybe you need to factor out the x, and that is the normal way to solve this. Okay. Uh, Actually, we will learn the normal way later on in I think in chapter 7, but I will give you a little bit introduction. Okay, so the normal way to solve this is you can factorize this, right? And this is called a partial fraction. Partial fraction. So this will be result in uh, two separate terms. And that is, this is x squared plus 1. This will be a constant a, and this will be a linear equation, let's say bx plus c. So first we need to find ABC. To find ABC. And how to do that? We can imagine trying to combine this, okay, trying to combine this, okay, and make some equation and take it equal with 1, okay, and that is how we find the ABC. It's a little bit long, but it's actually easy to follow. Okay, let me just show you. This is partial fraction, and it is one of the method in integrations, and we will learn more details about the partial fractions later. Okay, and this will be a right here, a x squared plus 1 plus bx plus c multiplied with x. And this should be equal 1. Okay. So we can try to calculate first, compute all the method, and we are grouping the variables. And we know that we got a is equal 1, right? A plus b is 0 because there is no x squared on the left side, and c is 0. And from here we got b is negative 1. So this will be resulted in 1 over x minus x over x squared plus 1. And take integral, and we can integrate in a easy way, right? This will resulting in ln x, and the right one here will resulting in, we can substitute, and then we have half ln x squared plus 1 and plus c. And if you want to combine this, we can combine and take it into negative half okay. It's actually ln and then over x squared plus 1, but I multiply with negative, so x squared plus 1 over x. This is the first method using partial fraction. The second method is we are going to use U-sub. We can use U-substitution. Okay. This is the key. Okay. So take the integrations, factor out. We need to factor out the highest degree. Factor out the highest degree x cubed. Okay. It seems odd, but this is will work. This become 1 plus this is x minus 2, right? Okay. Everyone follow? Okay. So this will be x cubed plus 1 plus x negative 2. Okay. Okay, I will switch the x cubed to the top equations, and this will be x minus 3. Okay. Can you use sub here? Can you substitute? Remember, if you have x minus 2, derive x minus 3. You can cancel with this. Right? Got it? Okay. So this is another way to look at it. Okay. So actually, you can use substitution. If you use u is 1 plus x minus 2, the u will be minus 2 x minus 3. So we will have negative half, okay? And we will have just 1 over u du. And this will be equal negative half, and ln u is 1 plus x with power of negative 2. This will be 1 over x squared plus c. Or this will be negative half ln. This will be x squared plus 1 over x squared plus c. Similar answer. Okay. So sometimes if you have this kind of questions, you try to factor out the highest degree. And that's also one way to solve. Okay, one way to solve. So substitution is more than you think, and more than you think. It can also solve this kind of problem. The normal way, we need to separate the fractions and integrate each one. Okay. So aside from so power functions, it can be positive, it can be negative. Okay. So it also works this way. Okay. I believe this will be the end of chapter 5. Okay, chapter 5. So chapter 5, this will include at least um, the definition of integral, with the definite integral, with the Riemann sum, with the sum, and then using limit, okay, of the area of the rectangle. That's the definition, and also the indefinite integral, fundamental theorem of calculus, okay, and the substitution method. That will be the chapter 5, okay, mostly about that. I'm skipping some parts on chapter 5.4 because that is mostly some related to physics, like how to relate the phenomenon like distance, velocity, accelerations, and how you make it into models. I skipped that for just focusing more on the integration itself. Okay. So your quiz will be chapter 5. Okay, chapter 5. I will maybe upload another exercise or maybe assignment. Just a few numbers that I think important. Okay. Because today I will move on to chapter 6. Okay, chapter 6, the application of integral, and the rest of the exercise for chapter 5 will be done with your TA. So next TA will be giving you some exercise on chapter 5. Okay. Let's start with the integral applications. Okay. So let me remind some basic from the previous chapter 5. Okay. If S is the region under the curve, so we know that the area under the curve, or S, okay, is equal integral from A to B of our f of x dx, and we already elaborate this in the previous one. So we first divide the area into some rectangle, and we approach with some approximations, and from limit definition we know that the area will be the integral from A to B of f of x dx. Now if we have now the problem here is uh, the limit or the restriction is this A here, x equal A, x equal B, the curve itself, and the x-axis, right? So that has at least 4 elements. Okay. So if we have two curves, okay, like this one, we have function f, and we have another one function g. Okay. Now, problem arises that can we estimate or measure this s, okay, the area of s, okay? Or in this case, this will be we call this problem. We need to find areas between curves. Okay. Now, firstly, similar to what we have done at the beginning of chapter 5, we can first divide this into rectangle. And we are going to see the difference is the height, right? The height will be different. Okay. Height. Before, our height just from x to f, or we can say the height is just f of x, right? Now we have additional height here, right? So if we divide and make it into like this one, take some sample point xi, okay, sample point. The height will be, we have f, and we have also this one will be a negative g, right? So the whole rectangle here, it will have the height of f of x minus g of x, okay? So that will be our new height. And similarly, we approximate the rectangle, we slice the area, making a lot of rectangles. Maybe we slice from maybe uh, 1, 2, 3, 4, 5, 6, 7, 8, 9 rectangle from A to B. We try to compute using the limit, or first we compute first. Okay, we compute that this is sum from it is f okay, okay. Now we have approximations that is, let me write with the this. So first we get the first definition on area between curves using limit. So when you have a lot of rectangles, the rectangles getting large, getting a lot, infinitely amount. Okay, you can approach with a limit, and have the integral. So you have these definitions now. So if you have the area bounded by two curves, okay, let's say the curves f of x and g of x, and you also have a bounded line, the interval, okay, x equal a, x equal b, the function is continuous, and the f of x is greater than g of x, then the default area, or the area between two curves, will be the integral from a to b f of x minus g of x dx. This f of x will give us the idea that it will have the position of f will be on the top above the g. Okay, so remember that this should be the case. F of x should be greater than g of x. But then, okay, then like for example, like this functions of sine, like that, and maybe having another functions like maybe another 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 functions like that in a trigonometry, right? If you have this in some interval, blue is above the red one. In another interval, is red is above the blue one. So we may have another term that is uh, suitable for this case. That is, we can just use f of x minus g of x, and it will depend on the interval. Okay? Because sometimes f may be on the top, maybe g sometimes on the top. Okay? And it depends on the equations, depends on the functions, and depends on the functions, and depends on the interval. Depends on the interval. Okay. So uh, generally speaking, the idea to solve the area between curves, firstly, it is better if you have the picture. If you have the picture. So if you can draw the graph, I think it will be better. It's to avoid a mistake, right? And sometimes when you calculate, and if the result is negative, maybe you have maybe you need to switch the f and g. Yeah. Maybe you pick the wrong function. Okay. For example, you get the answer is -1/3. And you think that area cannot be negative, right? So maybe it will be the other way around. Okay, other way around. Okay. So that's why probably draw first to make sure that you avoid those mistakes. Draw the image. Okay, let me give you a few examples as an introduction. So find the area of the region bounded by y equal e to the x and y equal x, bounded on the sides by x equals 0 and x equal 1. And we start from a simple example. Okay, we can start with maybe a simple drawing that is, I think, not really difficult to follow. Okay, now we have e to the x, this one. This is y equal x. And we know that this is our area. This is 0, this is 1. We can write down the integral from 0 to 1. This is e to the x minus x. And then dx. Okay. And we can compute easily this integration, not really that difficult. This will be e to the x minus half x squared, and then this will result from 0 to 1. This will be e minus half and minus 1 minus 0. So this will be e minus 3/2. Okay, of course, this one is pretty much, we are given all the information, the two curves, and then we are given the interval from 0 to 1. Okay. Sometimes the questions doesn't give you much information, so you need to explore yourself the other information. For example, find area of the region, and let me give you another terms also. Um, and enclose. Okay, it's the same with the bounded by, enclosed by uh, parabolas y equal x squared and y equal 2x minus x squared. First, we need to know which one from these two functions, two parabolas, that is on the top, right? And which one on the bottom. And we need to know what is the interval of our integrations, right? Okay. First, if you are maybe not sure, you can draw the curve. Draw the curve. Okay. When you are already familiar, you can directly calculate if you already know which one is on the top. But if not, then we can try to draw first. And I don't think the drawing is difficult because it's just a simple quadratic function, right? Simple function. Okay, if we look here, then this 2x minus x squared is, we can have x2 minus x. So the root will be x equals 0 and x equal 2, right? So we have the curve. Then this is our curve. Then this is the x squared. And the other one will be, this is 0, 1. I think I need to make it more thinner, maybe like this. Should be around here, but it's too small, right? Let me write. Okay. So the area is this small area here. Okay. If you want to make sure also, we can find the intersection. So intersection of these two parabola is x squared equal to x minus x squared. So 2x squared minus 2x is 0. So the intersections will be 2x, x minus 1. Intersection will be on 0 and 1. So this will be perfectly in line with our graph here. So this will be 0. This will be 1, 1. And you can find the intersection first and make sure with the graph. Okay, make sure with the graph. So the 2x minus x squared will be on the top in our case here. So we can input into our integral from 0 to 1 based on our intersection. This is 2x minus x squared minus x squared. Or this will be 2x minus x squared. Or we can evaluate, become 2. This will be half x squared minus 1 over 3 x cubed. From 0 to 1, we will have, this will be 1 over 6. This will be 1 over 3. Okay. So sometimes the questions didn't give you the interval. So the interval you need to find by yourself. And we find the interval by this intersection here. Okay. Finding the intersection. You find that this x is from 0 and x is 1. All right. Let me give you one more example. One more example that is usually we can have in some problems. So if we find the area of the region bounded by curves y equals sine x, y equals cosine x, line x equals 0, and line x equals pi over 2. Okay, now if you first start with the drawing, okay, we can draw the illustrations, the graph of sine and then cosine. First, the cos will be like that, okay, and the sine will be going up like that to maybe like that. So the area is between these two curves, x equals 0 and x equals pi over 2. Now we will have two conditions. Okay, the first condition is when the cos x is above the sine, and the other condition is when sine is over the cos. Okay, like I told you before. So probably we need to find the intersection here, and I think you can determine the result that this will be pi over 4, right? When the sine and cosine value is equal, right? So if you write it generally we can write the area as from 0 to pi over 2 using this absolute value here. We can write like this, and we can separate the integral with pi over 4 at the middle. And making into two integrals, cos minus sine and sine minus cos. You can try to compute and check the results. Okay. But however, what I want to tell you here is because this area is a symmetry. Okay. Again, it's symmetry. Okay. You can choose just one integrals from here, and you can multiply by 2, and it will be the same result. Okay, the same result. And I think it will be simplify your calculations. Okay. So you can simply say that because of the symmetry, because the symmetry, you can write the A is 2 or twice the 0 pi over 4 of cos x minus sin x dx. And you can calculate, I think, easily. This will result the sin x plus cos x from 0 to pi over 4. And this will be results on 2 squared of 2 plus minus 2, sorry. Okay, that is mostly the introductions, okay? The introductions for areas between curves, okay? And also, I forgot to tell you, uh, if you draw the graph, okay, don't forget to imagine the rectangle inside. The rectangle that is divide this integral. Okay? For example, in this case, we have this kind of rectangle, right? And slice up the area, okay? Because when we have more complicated problem, this rectangle can help us to identify how we can solve it. Because the next section is, it's not dx, but we will turn the rectangle into dy, okay? And we can also have that uh, uh, kind of functions, okay? So we will have a functions of y. So this will be areas between curves. This will be integrating or integrate with respect to y. Let me give you the general case for this kind of integral. So we will have maybe two curves, and we will have interval on y. Because AB we already used for x, let's write another CD, okay, another interval. So this will be, let's say, x equal function of y, f of y, and this one is x equal g of y. Or maybe I will write this outside here. Maybe resize a little bit smaller, maybe here. Okay. So the area will be in the middle, in between all of these lines and curves. And if we slice the rectangle, maybe using color yellow. And let's say that's our rectangle. It's like this. And let's say this is our delta y. Okay. And now the height of rectangle is, if we turn our head and we see that we have this length as our height of the rectangle, right? And the idea between this and the previous integration is just the same. The top equation minus the bottom one. If we look here, then this will be the top, this f, the top minus g, right? Okay. that will be the case. Okay? So we have the f of maybe here fy minus gy in general. In general, so we will have, okay. So with the same definition with the previous one, but the difference is just the functions. So we will have the area from C to D is f of y minus g of y, and then dy. Or if you want to write like with xr, xl, that is x right, x left, but I don't like it. So I just skip the top and bottom. Okay, you just rotate your head and look which one is the top, which one is the bottom. Okay. Okay, let's see how this integration will be useful. Okay, let me give you one example, and then we can, I think, if we have maybe another two example, but I don't think we have much time left. So I just give you one example. So find area enclosed by y equal x minus 1 and y equal, sorry, y squared equal 2x plus 6 is x minus 1. So first, probably you need to take some time to think how the graphs looks like. So probably you need to rewrite the equations within the x. Okay, and then we can draw. Okay. So maybe I will write the line first. This will be the line. This will be y equal x minus 1 or x now y plus 1. And the parabola, since it is uh, it's actually the transformation from y squared multiplied by half and then moving to the left minus 3. So we will have at least on 1, 2, 3. So this will be our for this, right? Okay, right. Green. At least we will have something like this. Okay. And I believe this will be result on so we will have some intersections between this line. So this is intersection, the red one here. So we have intersections, and we can find the intersections. We can find the intersections equaling both sides. We can give the intersections from there. So we will have or this will be results with y squared minus 2y minus 8. And this will be y minus 4, y plus 2. So we will have y is 4, y is negative 2. So this will be negative 2. Okay, this will be negative 2. Negative 1, negative 2. This will be 5 and 4. Now, the area is in between these two curves. Okay, if you using dx for integration, you will have some problem in this point here. Okay, if we draw the rectangle, if you draw the rectangle here, in this point, this is difficult to follow or to calculate, right? If we use the dx. One way to do it is we need to have two area. This one area here, and the area 2 is here. Okay, that's the way to use dx. But if we are using the dy, we are using dy. If we check on not it's not right. Sorry. If we are using the dy, there's nothing wrong within our equations, and I believe that is the way we are solving the integral. Okay, so we can solve the integral from negative 2 to 4, and this will be the y plus 1 minus the half y squared minus 3, and then dy. Okay. And you can solve later, and maybe I will show you on next Monday to have more examples. But from here, this kind of questions, sometimes you can solve both dx or dy, depends on the situations. And sometimes you need to separate between maybe 2 area, 3 area, 4 area. Okay. Yeah, I think that's the case. So identify the curve and identify which method you are going to use, integrate to y or integrate with respect to x, is also important. Okay? Sometimes the other will be taking longer writing, or the other one maybe it will be a short. Okay. 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 So we will have a feedback time, but before that, let me give you the QR code if you haven't scanned. And also, the midterm results will be on next week, the next week Friday, and we will have a quiz on Friday also. The quiz will be chapter 5. Okay, it will be about the definite integral, limit definition of the integral, the theorem, fundamental theorem of calculus, and also the substitutions method. if you so I hope you guys already scan QR code. Okay. Okay, wait a minute. Let me stop the presentation for a while. Okay, some feedback time. Okay, I just need to checking and evaluate, well, at least the first half of our lecture today. Okay. Okay, ready? Join. Okay, please join. Okay. Let's see. Okay, let's start the feedback. 3, 2, 1. Let's start now. Okay, 15 seconds. Short time because uh, you need to figure out quickly. Okay, good. Okay, good. Because it related to continuity, right? Okay, get ready. Okay, 3, 2, 1. Start. I hope the time is enough. Okay, good. It's 0. The answer is 0. It's odd function. Okay, next one. Okay, okay. The next one. 3, 2, 1. Okay, let's get through. Write in a fraction. For example, like A over B. Okay. I hope the time is sufficient enough. Okay, 5 seconds. Okay. 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 Good. All right. Okay. 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 Who is Bilala? Bilala. Okay. 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 So Bilala is pressing. Okay. So that will be the end of our lecture. So see you on Monday. Okay. So yeah, we will continue chapter 6. Okay, and on Tuesday you will have maybe exercise with your TA, and if I have time, I will add additional video for you. Okay, some for practice. Okay, so yeah, see you next Monday.